Welcome to the Clear to Send podcast, a podcast about wireless engineering, where we educate you on Wi-Fi technology, talk about design tips, troubleshooting, interviews, and the tools. Here are your hosts, Roel and Francois.
This episode is proudly sponsored by Metageek. For more than a decade, network professionals have used Metageek Wi-Fi tools to deploy, maintain, and troubleshoot wireless networks. Visit metageek.com/CTS and use the code CTS10 at checkout for 10% off your purchase of Metageek brand hardware and software. Hey everybody, welcome to a brand new episode of Clear to Send. I am joined with our co-host Francois. How are you doing, Francois?
Hi, Roel. I'm very good. How are you?
Oh, I'm doing great. I've been keeping myself pretty busy. Had a lot of challenging Wi-Fi issues this past week. Mainly, actually, interference, which is interesting.
Wow. Okay. Interesting.
I've had to deal with an issue where some clients weren't connecting to a specific channel, so I had to change the channels, which worked because in Clean Air, it was seeing a lot of non-802.11 interference. And it was a Uni 3 band, so I changed it. And so far, so good. A couple of other Wi-Fi issues. How's everything on your end?
That's good. I did some troubleshooting last week as well. It was interesting.
Are you able to share what the troubleshooting is, or we have to leave us hanging?
It was for a college. And so some students in the dorm room were complaining about poor Wi-Fi. So we found a couple of issues, coverage holes and drivers and a whole bunch of fun stuff.
So
it was interesting.
All across the board, right? All kinds of issues, not as a very specific type of issue, but just it's
PoE,
the worst case
whole
scenario.
Bunch of different stuff that adding up, created a poor user experience for them.
Oh man, that's terrible. But that kind of leads us into the main topic of this episode, which is useful Wi-Fi metrics to track, because this can gauge the quality of your Wi-Fi network. It can gauge if there's an issue that a lot of people are having, what you should look at. And so we outline 6 different Wi-Fi metrics that we like to track. Now, this isn't an exhaustive list, but these are some of the metrics that we gather in our own environment, some of the metrics that you will be familiar with, and then maybe some of them that you're not. But I guess, Francois, why don't you hit us off on the first Wi-Fi metric there that you like to track?
So the first one is RSSI, Receive Strength Signal Indicator. So that's pretty much the signal strength of a device. So that's the signal strength reported by the device itself. So it's reported by the Wi-Fi link. So the RSSI is going to be different from one equipment to another, from one device to another. Sometimes the same device will, let's say we take an example, an iPhone, like an iPhone 6. If you take 2 iPhone 6s at the same location, sometimes they will even report different RSSI levels. So it's very specific to the device, and it's telling us how well the device is hearing the Wi-Fi signal.
Yeah, and that's true, because there is no standard way of measuring RSSI. Every vendor has their own secret sauce that they use to determine RSSI, and also it's good to note that you can gather RSSI from the client's perspective and also from the AP's perspective, right? The AP can say, I hear that iPhone at -65, right? But maybe that might not be the same RSSI that the client hears the AP from, because the radios are completely different. The receive sensitivity is also different. So this one's a hard one to track, but it's a good number to look at, in my opinion, because that is your basic coverage indicator.
Yes. The client device will be taking a lot of decisions based on the RSSI level.
Mm-hmm.
right?
And that
So
and that's actually used
that's
in
why it's a
ways
good metric to
of,
track.
of roaming to another AP, right? Some vendors might be sensitive with RSSI, where others might use other metrics to determine roaming or when they want to switch to a new AP. But a lot of the times we don't even know what that information is, unfortunately.
Yeah. So RSSI is pretty much the one you see, when they show you like the bars, the Wi-Fi bars.
Mm-hmm.
That's pretty much what they're reporting, the RSSI.
Yeah, and I've heard that that's not even a good, clear way of knowing what your signal strength is, because it's not like 4 bars equals, I don't know, negative 40 RSSI, right? It's just, I guess it's a feel-good symbol of your signal strength.
Like on macOS, if you connect it to a Wi-Fi network, it will show you like full bars, even though your signal is very poor. If you use an application like Wi-Fi Signal from Adrian, you will see that even though you get like a minus 80 dBm RSSI, you will still get like full bar if you connect it if you associate it to this specific Wi-Fi network. On Windows, I know they use a percentage, so they would tell you the signal is you have a signal of 80%. The quality of your signal is 80%. You don't really know what's hidden.
Yeah, what is that exactly? What does that even mean, or what does that translate to signal RSSI values? But I guess if you're looking at RSSI, you want to know what your average RSSI is with all your clients, and then that can help you determine maybe there isn't enough coverage in your environment. Maybe you need to add another access point or 2 to fill the coverage as needed, or maybe turn on another radio if you've turned off a couple of radios, or maybe even transmit power. Maybe your transmit power is a little too low. All this can affect RSSI from the client and also from the AP.
And if you're troubleshooting a specific client, it's usually good to check directly on the client what type of RSSI the client is reporting. So you have a really good idea of what the client is seeing, and how well the client is seeing the Wi-Fi signal. Some good numbers in terms of RSSI. We usually say that if you want good voice over Wi-Fi services, you need minus 65, 67 dBm, a minimum. For typical connections, I would say minus 70 dBm is good.
Yeah, some basic.
And then if you go
traffic
lower than minus 80, it's going to be a poor experience.
Yeah, I don't like seeing negative 70 just in my environment, because a lot of the people that I work with, or a lot of people that are using my Wi-Fi network, they tend to be intense applications. So either video, or they're doing some sort of audio calls through their computers, and that really affects the quality of their experience using the application. So I try to stick around negative 65, negative 67, because I just assume they're going to use some sort of voice application, whether that's a soft phone on your computer, or maybe if it's a soft phone on your phone and you're connected to your Wi-Fi network. You just never know in my environment, just because it's a BYOD environment.
And the quality of the connection will not. Yeah, tell me.
Go ahead.
No, I was going to say the quality of the connection will not only depend on the RSSI, but will also depend on the level of noise you have. And that's why we have the SNR.
Yeah. So that's a good segue into the second metric, Wi-Fi metric to track, which is SNR, or signal to noise ratio. And to me, that's an indication of the actual quality of that signal, because it's the difference between your RSSI and the noise floor of the environment. Wouldn't you agree, Francois?
Yes. So if you might have like a really good signal quality, but if the level of noise is high, you might have a poor experience on the Wi-Fi, and the SNR would be driving which type of modulation is used to encode the RF. And so if you want to use complex modulation techniques, you need a good signal quantity. You need your signal to be far away from the noise. So you'll be able to use those complex modulation techniques and send more data across the RF.
That's true. The higher data rates that we need to use, the more complex modulation schemes have to be used. But that also means your SNR has to be almost flawless for those types of connections. And also, it's the way that devices process SNR, it's only 802.11 traffic that they can demodulate, which becomes the part of the SNR calculations, because the client's radios are not spectrum analyzers, so they cannot actually, they can detect energy, but they can't demodulate non-802.11 traffic. So I don't know whether or not some of those clients take that energy, non-802.11 energy, into consideration into the SNR. Do they factor
I don't believe
that
they
as
do.
noise?
Yeah. The Wi-Fi NIC will have, into any client device, you'll have the first filter, which is the frequency filter. So this filter is happening through the antennas. So basically, the client will only filters out the 2.4 and the 5 gig signal, and then you have the modulation filter. And so the client NIC will try to demodulate the signal and try to see if it's a Wi-Fi, it's Wi-Fi packets. And if it's not, it will just discard it. And then after that, I think that's when the noise is calculated. If the modulations didn't work perfectly, or if the packets was detected with some type of errors, then it's considered as noise. That's how I understood it.
Yeah, and what we don't know though is if every vendor or manufacturer does it the same as far as calculation of SNR. And I think that's probably one of our biggest issues. I'm always going to point it down to the actual client driver device, because everyone does it differently. But for those of you that don't understand SNR or are just getting familiar, a perfect example is a concert where, let's say you and I, Francois, are watching a concert live. It's loud, it's noisy, music's playing, and I try to say something to you. You're standing right beside me, but I have to yell it to you so you can hear me. You can demodulate what words I'm saying. But I have to yell that above the noise of the crowd, the music, everyone else screaming. That's the actual noise floor. And then me yelling loud enough for you to understand what I'm saying. That's the signal you're receiving. And the difference between that is our SNR.
Yeah, and in Wi-Fi, the noise will be made of other Wi-Fi signal from neighboring APs, and also from other wireless technologies using the same frequencies.
Yep. And I guess we can talk about the third useful Wi-Fi metric, because SNR will play into this as well, which is channel utilization. And if you're in maybe, a lot of times this happens in the high density areas. If you don't have enough capacity, your access points are going to hit high channel utilization with every single device trying to transmit or receive traffic. And this can affect the quality of the signal, because this is how busy your channel is, right? The channel that's serving your clients. And this can be calculated based on 802.11 traffic, the actual Wi-Fi traffic, but the channel utilization also takes into consideration of non-802.11 traffic. So you're able to measure how busy that channel is with both traffic and also interference. And that will be able to tell you the quality of that area where you're serving and the capacity, because that's going to really affect, even if you have great RSSI, And if you have great SNR, but we have to consider channel utilization there as well. You have anything else to add to channel utilization, Francois?
Yeah, I really like channel utilization because it also tells you how busy the overall environment is, right? So it's going to tell you if you have noisy neighbors. When I say noisy neighbors, I mean like very active neighbors on different channels. Sometimes they will be using the conventional channels 1.6.11. Sometimes they'll be using other, channels, creating even more noise. But it basically tells you how busy your channel is and if you have any capacity on your channels. And it also tells you, when CCI becomes an issue, right? You can tolerate a little bit of CCI if you don't have too much traffic going on.
Too much traffic.
But if you have a lot of traffic, then your CCI will just become an issue, right?
Yeah, it'll raise your channel utilization because now you have two APs serving fairly close areas on the same channel. They're all using the same contention domain, and it's the same capacity that's being shared with all those devices on the same channel. So therefore, your channel utilization is going to go up through the roof. And this is terrible for scenarios such as your high density areas where you need to actually create contention domains.
Exactly. And I found that when you start looking at channel utilization and what make the, what type of traffic is using the channel, you start to realize how, how much overhead the Wi-Fi protocol itself is generating. You're going to see a lot of control frames. You're going to see a lot of management frames. So even for those starting, working on Wi-Fi, it's a really good metric because it forces you to try to see what's going on the frequency, and you can really learn how everything works.
Okay. Yeah, that's a good point.
I don't know if you've ever seen it that way. But in a very in a non-active environment, you're not going to see a lot of data frames. You'll be seeing a lot of control frames.
I've definitely seen
in your environment
a lot of overhead is what I call it because of one. There could be too many SSIDs as an example, right? Where it's just a lot of management traffic going through. This is why we tell people
or CTS, RTS.
Don't do more than 3 SSIDs.
Yeah. So in your type of environment, what type of channel utilization do you have? Like when you have a class going on in?
Oh, I'll see in an environment where we need to redesign it because it's just been designed for coverage back in the day. I'll see it go through the roof where it's in my spectrum analyzer. I'll see it over 80% utilized.
Okay.
And then what I do is I document, what I find. I redesign it, add more capacity. I have more channels available to use. And then on top of that, I'll use, external antennas instead of omnidirectional antennas. And then I can start to see the distribution of capacity on different channels and see lower channel utilization. But aggregate, that could be about 100% of what I saw from the previous design. But now it's spread out across 4 channels as an example instead of just 1. This episode is proudly sponsored by IPA, the visual packet analysis software from MetaGeek. As a Wi-Fi professional, you probably understand the benefit of packet analysis for troubleshooting wireless issues. And if you have any experience with most common packet analysis solutions out there, you also understand that sifting through hundreds of lines of data to find the cause of a network problem is a little like looking for a needle in a haystack. IPA takes a visual approach to wireless frame analysis. So instead of dumping raw packets for you to evaluate, IPA presents your data in multi-layered pie charts that make it easy to understand which networks, devices, and packets are using your available wireless airtime. With fast and easy filtering options, color-coded labels to show data throughput versus management overhead, and expert tips based on observed conditions, IPA makes 802.11 frame analysis easier than ever. Visit metageek.com/CTS and use the code CTS10 for 10% off your purchase of IPA.
Yeah. That's pretty good. I think the maximum I've seen was 90% channel utilization.
Yeah.
But at that point, nothing was working. Like you couldn't even add another client onto the Wi-Fi network.
Yeah, users will consider that as completely unusable because it's true.
Yeah,
it's not usable at all. And some of the most simplest websites will not load in that scenario.
Yeah. And you know what? The AP sometimes we forget about that, but the AP has to contend to user frequency as well, right?
Yeah.
So sometimes you won't even see the Wi-Fi network when you scan for Wi-Fi networks if it's really busy because the AP doesn't have the time to send it's a beacon.
Yeah, it's waiting. It's going, okay, all these clients are sending something, but then now that other AP wants to send something. And that's why always adding, when they say add another AP to fill capacity or something, sometimes that's not always the case. Like there could be too much APs and that could be a problem.
I've had a situation where I worked on this project. I had 3 APs on channel 1, 3 APs on channel 6, and 3 APs on channel 11. They could all see each other. And I had like channel utilization up to 80%. I only left 1 AP on each channel, and I brought my channel utilization back down to 60%.
Oh, wow. Yeah. That's a huge difference. This is the classic scenario I hear from a lot of people, which is just turn off some of your 2.4 radios, and I bet you'll see a huge improvement.
Yeah.
And then utilize those 5 gig channels. Make sure those clients are 5 gig capable. They should be nowadays. There should be no more 2.4 only devices. I don't understand.
So yeah, channel utilization. I like how on the new Cisco wireless interface, you can see channel utilization right when you go into the AP page.
Mm-hmm. Yeah, it's just right there, right in front of you. It's one of the first things you see. And that dashboard you see there is supposed to help you try to determine whether or not you've got an issue, right? And I think it's great to see it in easy display format, because the way you'd normally see that is within Clean Air. This is something we spoke about in our last episode on Clean Air, is when you go look at your air quality report, it will show you the channel utilization, but it's just not as nice as the new dashboard does.
Yeah, and some APs report the channel utilization in an information element in one of their management frames. And if you use the Wi-Fi Explorer on the Mac,
if you're using a Mac and you're using Wi-Fi Explorer, that is useful because it's a column that you could actually activate, and it's channel utilization. Don't be concerned if you don't see anything for channel utilization for an SSID, and that's like what Francois said, is some APs just are not putting the channel utilization in the information element, so then therefore Wi-Fi Explorer just doesn't see it. And that's a quick way. I think Wi-Fi Explorer is a great tool for this, right? To see some of these metrics we're talking about, which is your RSSI, SNR, and channel utilization. And trust me, you can go look at your 2.4 environment. If you have a lot of channel overlap, turn off some 2.4 radios, and you'll see that channel utilization go down. And then also some other things, some other metrics might go down as well, which we'll actually get into. So why don't we just move on to the next Wi-Fi metric to track? Our fourth one is data rate. This is a touchy subject for a lot of people. What do you think, Francois, about data rate?
Yeah. Data rate, I like to look at data rates from the client perspective. Especially when I do troubleshooting. I want to see what type of data rate the client is using. It's going to tell me, it's going to tell me if the, the client can use the more complex modulation techniques, if it's receiving a good enough signal to use the more complex modulation techniques. it's also going, if I see some weird behaviors related to data rates, maybe it can lead me to some driver issues or things like that. In order to track data rates on the client side, I like to use the application called the Bookie on Mac, because it shows you all your clients, and then in real time it shows you the data rates and other metrics from the client perspective. So I really like this application. I've talked about it on the show before, but it's really nice to track data rates.
Yeah, and one of the when we're looking at or talking about data rates as well, one of the things I like to look at is what is the minimum data rate enabled in the environment, because I've seen some environments enable or make the minimum too high, and I can see that as being a problem because maybe when we look at an AP that has a high transmit power, that client will sometimes think the AP is really close, right? So it's going to say, that AP is so close to me, I'm going to transmit my data at the highest data rate that I could use. So it transmits its traffic at the highest data rate, but then the AP can't demodulate that signal for whatever reason. Maybe the client was too far and it just didn't get demodulated by the AP, and then therefore it causes a retry, right? And then so the client tries a lower data rate, just steps it down, and then you'll actually see the data rate jumping around quite a bit depending on the environment. And the one thing I remember clearly is Jerome Henry did a presentation on this back at Cisco Live, where he documented a client's data rates just, it's just like just going up and down constantly, trying to do different data rates. And my suggestion is to always start with, say, a lower data rate as your minimum, like 12. I don't like starting at the highest data rate.
Yeah. That's a very good point, actually. And also, so look at the minimum data rate. And also, when you're troubleshooting a client, you can also look at the maximum data rate they support. Mm-hmm. And it will tell you, like, if the max they support is 144, or 300, whatever, and then you can correlate to whatever you're measuring at the moment to see if they're meeting their maximum capacity or not.
Mm-hmm. And what do you think about disabling some of those on your controllers? Do you like to leave some of the? Like, do you like to leave some? Like, do you ever disable some of those higher data rates?
No, I've never tried.
You leave them supported.
Yeah, I usually disable the lower data rates.
Yeah, I disable the lower ones, especially the B data rates. But I think
I've never. Yeah,
I think what's good to monitor with data rates. And I've heard Keith Parsons talk about this quite a bit, which actually ties into our next metric, which is the retry rate. And for me, the retry rate, I do not like seeing that in upwards of 10 to 15% retries in your environment. I think when you have a retry rate that high, average in your environment, you have to look at what's causing this high retry rate. Is it because your minimum data rates are set too high? That's one thing to look at. And if you're starting to gather these metrics, let's say you lower the minimum data rate, does also the retry rate drop as well? That's something to look at. I think Keith Parsons has talked about that quite a bit, and I thought that was an actual good information to look at if you're trying to troubleshoot your environment and see whether or not the change was a good change or a bad change. Because retry rates will actually help make your network crawl, right? It's because devices have to be quiet for a certain amount of time, and then devices resend the data they had to resend, and just sometimes we're seeing like potential interference causing these retry rates. I don't know if hidden nodes are still a problem in environments, or even devices with bad drivers, I've seen that causing retry rates go through the roof. I've had to troubleshoot that in one of my buildings where an 802.11 device just started spewing out traffic. It was doing 100% duty cycle on a 2.4 channel. We had 2.4 only devices, and using a spectrum analyzer, I actually used the MetaGeek, the patch antenna to locate this device.
The finder, yeah.
Yeah, and just saw that this device was just screwy. I think either drivers were bad or the antenna went bad, something. But that caused the retry rate for the whole environment to go through the roof, and it's
wow.
Sometimes you just don't see that problem on a controller, as an example.
Yeah, retries are bad because the usually it's sent at the lower data rate.
Mm-hmm.
The retry packet is sent at the lower data rate, and the interframe space in between the frames are also longer, so it's using more airtime, and it's decreasing the capacity of your network. So it's bad.
Yeah,
I had a question for you, Roel. Can you track retry rate in Voyance of Nyanza?
I can't recall off the top of my head. I don't think so.
Because I'll
have to check.
That would be that would be useful if they can tell you, like, this is the type of retry you had before the change, and then this is what you have after the change. And keep track of that for you.
I think it does. I think it's one of the potential root causes. It'll say it's a high retry rate. Actually, yeah, now that I think about it, if you look at a device in Nyanza, there is a graph which shows layer 2 retries. And if that's always high, then that's a problem. And you could see that for individual clients. You can probably, since all that data is being collected, you could probably nail it down to even specific vendors. What kind of manufacturer?
What I always find complicated with specific clients is that you don't know if the client is far away from the AP. The client might be just isolated and very far away with the low signal strength and generating a lot of retries, but it doesn't really mean the client is actively connected and using the Wi-Fi. You know what I mean?
Yeah, exactly. And it's one of those things where if you have all the metrics and the information, the data, you can try to get to the resolution faster, right? You can start eliminating potential issues and try to drive through to the actual solution. And that's where a lot of these tools come into play. And I think also MIST systems will also list the retry rate. They have what they call service level agreements, I think, or SLEs, I think is what they call them. And they have a dashboard that shows, how your network is performing, and they'll have things, I think they have a retry rate. But that's one of the metrics I watch. And if I'm troubleshooting in an area, a specific area, I actually just use Wireshark, and I will start capturing packets or frames in the area. And I will actually filter down just to show retry rates only. So if I'm capturing for, 10 minutes, I can see how many of those frames within that 10 minutes are retry frames.
Yeah.
And I'll start troubleshooting that way as well. And
I remember troubleshooting a few years back. I did troubleshooting in a warehouse. And they had a lot of metal around, and they were using G-only guns. So the RF guns were not supporting MIMO. And we had a retry rate of like 40%, I think, before we fixed the issues. But it was very high due to, reflection of the signal being altered along the way, and then the clients were not being able to modulate the signal. And anyway, yeah. It was a mess. So that type of issues.
What was the solution there? Upgrade the devices?
It was a complicated case, but we ended up changing the type of antenna they were using. They were using omnidirectional antennas. We used directional antennas.
Yes, I love directional
and we
antennas.
fixed a lot of their issues. Yeah.
Yeah, because directional antennas, you can focus the signal where you want it to be, whereas omnidirectional is just everywhere. You can't control where the signal is going. It's just everywhere. And that's why I like directional antennas. But, it does increase the cost of the whole installation. But what is the cost of Wi-Fi not working? Probably lost a lot more money.
I was going to say, what's the cost of Wi-Fi troubleshooting?
All right, let's talk about our last metric. This is our sixth one, and I added this one in there, association time. Right? How long does it take a device to actually associate to the AP, to the network? And why would we even consider this a metric? Because if people are taking a long time to just join the network, to join the Wi-Fi network, I think that would be a problem. For one, why would this be a problem? Like, how does it even occur? And you and I were talking about this earlier because I was trying to figure out more than one reason why this would happen. And you actually came up with a few, which was like band steering is a good example where we have 2.4 only devices, but you have band steering enabled. And so those 2.4 responses are being delayed. So that makes association take longer for that device, which is not ideal, wouldn't you say?
And you also have the case where the client will prefer 5 gig. So the client will send their probe request on 5 gig first. But if your Wi-Fi network only supports 2.4 gig, you might wait a little longer before getting connected, because the client will go through all the channels on the 5 gig before reaching the 2.4 gig channels. Yeah.
And then there's also APs that are broadcasting on DFS channels, and some devices don't send probes on those DFS channels. I think there's some certain conditions, and I try to find this, and I know we've had this discussion before on Twitter about DFS channels and the way client devices actually scan for APs on channels and DFS channels. I think it's like the scan time, or if there isn't a beacon heard on a DFS channel, it won't try to scan on that channel. If anyone has that document that talks about this, please let me know. It's just I can't quite pin it down, and I know I've seen this before, and I know that would cause a long association time. And then you mentioned the client support for the band or channel. I also mentioned that. And then also it's whether or not the client can hear the AP or the AP can hear the client. That's another problem as well. And that would cause a long association time. And so far, I think there's only 2 vendors I can think of that actually monitor this metric. And the first one is Cape Networks. Cape Networks has a sensor that you could deploy out into your environment. It looks like a small AP, but it is a Wi-Fi client. It'll actually keep track of how long it took to associate to a specific SSID. The second one is Mist Systems. There's a indicator there of how long it took. What is the average time it takes clients to associate to the Wi-Fi network? And I want to say Mojo Networks also does that as well in their dashboard to show the average time to associate. But I think those are good metrics to gather. Do you have anything else to say about association time, Francois?
No, I would say also it would be interesting to know the authentication time. If you have like 802.1x authentication, with the different exchange with the Redis server, it's interesting to know how long everything takes.
Yeah. And it's good to know if it's even the Radius server maybe that's causing the delay.
Yeah, understand where the Redis server is located in your network. Understand if you can make it, make the whole process faster.
Maybe you need to turn on 802.11r as an example.
Yeah, for roaming, yeah.
Yeah, and I could see also tracking, the roaming time, because if you're going to do 802.1x, you want to make sure that the time to roam doesn't take too long, right? Especially if you have low latency applications where that roaming time could affect the stability of that application, especially VoIP. Those are applications you want to be able to validate when you deploy 802.1x and 802.11r and everything that to try to help the roaming process faster.
Yeah.
Guess that's the bonus metrics.
Yeah.
All right. So we talked about 6 metrics. We talked about RSSI, SNR, channel utilization, data rate, retry rate, and association time. Then we added some bonus ones in there. We talked about roaming and authentication because of like radius, or how long does it take to authenticate to the Wi-Fi network. Those are the useful Wi-Fi metrics that we track in our environment, and I'm sure there's a lot more others that should be tracked. It just depends on your environment. We'd like to know, what are those metrics, right? So if you want to add to this discussion, go ahead and head over to the show notes. That's cleartosend.net/108 and leave a comment down below. Or you can hit us up on Twitter with hashtag CTS108 with what your metrics that you watch and you find that useful and why. And I think this would serve as a good education for many people out there as they're trying to figure out, okay, what can I do to track my Wi-Fi network, and what resources can I use that'll help me figure out what those metrics are. So we want to thank you guys for listening to this episode. We hope you found it useful. If so, please do share this episode with your friends and colleagues, and don't forget to leave us a review on iTunes. Let us know how we're doing. And like always, you could reach me on Twitter at Roel Dionisio, or you can hit us up at ClearToSend. Francois, where can they find you?
On Twitter at Verges Francois, or at the CTS Twitter handle as well.
Awesome. Well, we want to thank you guys again for listening. Oh, before I forget, we had a giveaway. Let me just mention who that is. I'm just going to I use a random number generator on Google. And so I pulled number 11. Number 11 is 1, 2, 3, 4, 6, 7, 8, 10, Robert. So I will send them.
Who's number 11?
Robert. I don't know who the last name. I exported the list as we were chatting because I didn't want to forget, and I didn't grab the last name. But Robert, I will send you an email, and you let me know if you want a shirt or a sweater, and we'll send you a ClearToSend piece of apparel. Please take a picture of it. We would love to see how it looks. Let us know what you think. But congratulations. And that was our giveaway from last week, the CTS apparel giveaway. And we have more giveaways to come in the future. But thank you guys for those who participated. Thank you for participating and leaving comments and whatnot. We greatly appreciate it. So thank you guys for listening. We will see you on the next episode.
See you guys. Bye-bye.